Hello, students, and today we're going to learn about combining like terms and the parts of an expression. So the first thing you notice in this big expression is that there is no equal sign, and an expression does not have an equal sign. That's how it's an expression. No equal sign, okay? So the terms in an expression are separated by positive and negative signs, or we say addition and subtraction. And when I separate the terms in this expression, I will always include the sign that is in front of each number. So when I look at it like this expression has 1, 2, 3, 4, 5, 6 terms. In front of 7x, we have an invisible positive term. So the kinds of terms that we have are terms with a variable, and the variable are the letters. In this case, we're using x. So the variable terms in this expression are 7x, negative 5x, because I'm including that negative sign, and 4x. Now, the constant terms in this expression here, still looking at the same expression, are 3, 8, and 1. Here's our 3, our 8, and our 1. The coefficients are the terms, the numbers that are in front of the variable. So let's use another color so we can circle those. The coefficients here are 7, 5, and 4. And remember, we use the negative sign and we include that. So that would be 7, negative 5, and 4. So now let's look at some expressions and see if we can simplify those expressions by combining like terms. Well, first we have this expression, where it says, looking right here, you can simplify an algebraic expression by combining like terms. This means to combine common variable terms and constant terms. So we are asked to simplify the expression below. So I'm going to underline everything that's the same that I need to combine. So I have 7x, that's a like term with negative 5x, and with 4x. So I just add the coefficients in the front. 7 minus 5 is 2, plus 4 is 6, so that gives me 6x. Now I'm going to go ahead and I'm going to change my color, and I'm going to add the constants. I have a positive 3, a positive 8, and a negative 1. 3 plus 8 make 11, minus 1 is 10, so it's positive 10. So this expression simplifies to 6x plus 10. Now let's go on to these other expressions. I have 3x plus 6x. Can I combine them? I can, for 9x. Now here I'm going to combine a 7m and a negative 5m. So 7 minus 5 is negative 2. Is positive 2. Oops, sorry. Okay, get my color back. I subtracted 7 from 5 instead of 5 from 7. So that would be 2m, and then I have this minus 6. Okay, moving down, I'll do the odd numbers first. I have 7p minus 9p, which is negative 2p. And then I have this negative 1 plus 5, which equal positive 4. And these are our final answers. I'm going to go ahead and put those in boxes. And let's do this last one. At the bottom, I have 5x minus x plus 3x. Well, 5 plus 3 is 8. minus 1, this is an invisible 1 here, so 8 minus 1 is 7, 7x. Now let's look at the y terms. I have a positive 7 and a positive 2, so that's 7x plus 9y. So I want you to take a minute and I want you to do number 2, 4, 6, and 8 before we move on. So please pause the video and work on those. Okay, hopefully you've paused and you've tried those on your own. I have 9a take away 10a, which is going to give me negative 1a, but we don't write the 1 in front of a variable. That's an invisible 1, so that's negative a. Here we have 9 minus 6w plus 5. That 6w is on its own. It doesn't change. So we have negative 6w, and we have 9 plus 5 equals a positive 14, and that's our final answer. In the next set, we'll combine the h's first. 5h plus 7h gives us 12h. And then we have negative 6 minus 8, which is negative 14. And there's our final answer, 12h minus 14. And now we have 26a minus 4a. So 26 minus 4 is 22a. And now we've got that positive 2b plus 10b. 2 plus 10 is 12, so that's plus 12b. And that's the answer to that section. So let's take a pause. We'll switch to the next page and we'll work on those. Okay, let's finish up our lesson on combining like terms. Here we have some examples with exponents. Important to note that terms with the same exponents or the same combination of variables and exponents are considered like terms. They must be the same exponent or the same combination of variables and exponents in order to be considered like terms. Excuse me. When you combine these, be sure you do not change their exponents. So here in number 9, I have 5x squared plus 7x squared. We can combine them, and our final expression is 7 plus 5 is 12, 12x squared. In our next example, we'll go straight down and do the odd numbers first. We can combine the 8c cubed, the negative 7c cubed, and the 16c cubed. 8 minus 7 is 1c cubed, and 1 plus 16 is 17c cubed. Here we have a negative 4a squared b plus 10a squared b. Negative 4 plus 10 is 6a squared b. And the 7 here is on its own, but we don't leave it out. 6a squared b plus 7. And number 15, we have an a squared. And that's all we have. It's on its own. So we'll just write that down. We're done with the a squared. Now we've got a positive 7ab and a negative 10ab. 7 minus 10 is negative 3ab, and the b squared is on its own. And it's a positive b squared. That's an invisible 1, 1b squared. So I want you to take a minute, and I want you to do the next group on your own, and then come back and you can check your work. Okay, now that you've done these on your own, let's see how you did. We have a negative 15 n5 n to the 5th plus 4 n to the 5th. Negative 15 plus 4 is negative 11 n to the 5th power. Here we have 8k squared minus 1k squared. Oh, I'm sorry, that's a minus k. We're not going to do that yet. We have 8k squared minus 2k squared. So 8 minus 2 is 6k squared. And now we have negative 1. We have an invisible 1 here. Negative 1k minus 5k. Negative 1 minus 5 is negative 6k. And our constant will be at the end all by itself. And I hope you're looking at the order that we're writing these in as well. We go in ABC order, alphabetical order. The constant is always at the end, and we use the highest degree first when we list the terms of these expressions. So let's move on to number 14. I have x squared, 1x squared. There's an invisible 1 there. And that's it for our x squared. I just want to get my eraser and erase that a little bit and start over. So we have 1x squared. So we'll go ahead and write that down. Now let's look at the xy terms. We have plus 2 minus 7. So that's 2 minus 7 is negative 5xy. And then we have the 4y squared on its own. And that is a complete answer. And number 16, we will start with the x squared. We have 4 minus 3. So 4 minus 3 is 1. That'll become an invisible 1. So that's x squared. Then we'll look at the x terms. We have positive 2 plus 8. So 2 plus 8 is 10x. And then the constants, we have negative 7 minus 6, which will give us minus 13 for our constant. And there's our final answer. Here we have some geometric applications, and they ask us to give the perimeter of each figure as a simplified expression. Perimeter is the distance around the object, like this purple line I just wrote. So we'll start here with the x terms. We have an invisible 1 here. So we have 1 plus 3 is 4, plus 2 more is 6x, plus, and then the only other thing we have is this 1 term here. So the distance, the perimeter around this triangle is 6x plus 1. Let's take a look at this right angle triangle. So we'll start with the a terms. We have 5 minus 1, there's an invisible 1, so that's 4a. And now we'll look at the AB term. All we have is this 4AB here, so we're done with that. We can cross that out and that if we want, if that helps you. So we have plus 4AB, and here we have negative 1 plus 17, or 17 minus 1, which is simply 16. So 4a plus 4ab plus 16 is the distance around this right triangle. Now let's look at number 19. We're looking at this rectangle, and we see these symbols that tell us these are all right angles. And that tells us this is a right angle. This side on the left equals the same distance as the side on the right. The horizontal line at the top equals the horizontal line on the bottom. So what that tells us is that this distance here is also 3y minus 5, and this distance here on the left is also y plus 2. So let's start with the y terms. We have 3 plus 3 equals 6, plus 1 more is 7, plus 1 more is 8. We have 8y. Now here we have 2 plus 2, which is 4, minus 5 minus 5. So that's 4 minus 10, which gives us negative 6. And finally, we have this parallelogram. It's actually trapezoid. We have one set of parallel sides. That would be the top and the bottom. And we are given the measurements, and obviously these two sides are the same, but the top is much shorter than the bottom. So we're going to start with the k squared terms. We have 2k squared. There's another k squared, so we have 2 plus 1 is 3, plus 1 more is 4, plus 1 more is 5. That gives us 5k squared. Now let's look at the k terms. We have negative 9 plus 1, that makes it negative 8, plus 1 more, which makes it negative 7k. And let's do the constants. We have positive 23 minus 17. 23 minus 17 is a positive 6. So the distance around that figure is 5k squared minus 7k plus 6. So I hope you were able to do most of those on your own without too much help. For tonight, you have a homework assignment that goes with this lesson, and best wishes and work hard. I know you can do it.